In today's episode, you will learn how to make your own power line frequency or mains frequency monitoring system. This is the third part of the SCADA application-based grid station parameters monitoring system, while the first part was based on AC voltage monitoring system, in which we successfully monitored the normal voltage, overvoltage and undervoltage. So far, we can monitor the voltage and load on our SCADA application. If we increase the voltage above a predefined value, it will provide automatic disconnection. As you can see, the LED is turned off, while during the normal voltage the LED remains on. Now if I decrease the voltage below a certain predefined value, it will provide automatic disconnection and the LED will turn off. At the end, we will connect a relay with pin number 13 so that in case of overvoltage or undervoltage, the supply can be disconnected to protect our appliances from any damage. While the second part was based on load monitoring system. As you can see, currently the load status is normal as only one bulb is connected. If I connect another bulb, the load will be increased. And now you can see on screen the load status is overload. The load value can be set in the programming as per your requirements. The links are given in the description if in case you want to learn how to monitor the AC line voltage and load. As you know, my friends, today's episode is about the power line frequency or mains frequency monitoring system. In this episode, we will cover number 1, complete circuit explanation, number 2, soldering, number 3, programming, and finally number 4, testing. Let's get started. The components that we will be needing for the frequency monitoring system are number 1, Arduino, number 2, 12-volt step-down transformer, number 3, a Vero board, number 4, a bridge rectifier. As you can see, it has 4 legs. 2 legs are labeled with AC signs. This is where we connect the secondary wires of the transformer, while the remaining 2 legs are labeled with plus and minus. The DC voltage will be available on plus leg, while negative leg is the ground. Number 5, 10K resistors. We will need 4 of these. Number 6, 2N2222 NPN transistor. The left leg is the emitter. The middle one is the base, while the rightmost leg is the collector. Number 7, 16x2 LCD. Number 8, a variable resistor or potentiometer, and finally number 9, connection wires. These components can be purchased from Amazon. The components purchase links are given in the description. This is the complete circuit diagram of the power line frequency or mains frequency monitoring system. This schematic is designed in CADSoft Eagle 9.1.0 version. If you want to learn how to make schematics and PCBs, then watch my tutorials. The links are given in the description. 220-volt AC is connected with the primary side of the 12-volt step-down transformer. The secondary side of the transformer is connected with the AC legs of the bridge rectifier, while the plus and minus legs of the rectifier are connected with the series resistors. These resistors are used to reduce the voltage. As you can see, for 12 volt we get 4 volts, which is perfect for 2N2222 NPN transistor. Make sure you never exceed 6 volts, as voltage greater than 6 volts can damage the base of 2N2222 NPN transistor. If you get voltage greater than 6 volts, then use another resistor in series. It will further reduce the voltage. As you can see, for different input voltages we get different voltages from the voltage divider circuit. The emitter of the 2N2222 NPN transistor is connected with the ground, while the collector of the 2N2222 NPN transistor is connected with a 10K resistor. This is a pull-up resistor. A wire from the collector is connected with pin number 2 of the Arduino. As you can see, ground is connected with pin number 1, 5 and pin number 16. 5 volts from Arduino is connected with pin number 2 and pin number 15. The middle pin of the variable resistor or potentiometer is connected with pin number 3 of the LCD, while the other two pins are connected with ground and 5 volt. Pins 4 to 7 of the Arduino are connected with pins D7 to D4 of the LCD. Pin number 8 of the Arduino is connected with the enable pin of the LCD. Pin number 9 of the Arduino is connected with the RS pin of LCD. Now let's start the soldering. Fix the transformer on a Vero board using silicone or screws. Insert the bridge rectifier into the Vero board. Now connect a 10K resistor with the positive leg of the bridge rectifier. Now connect 2 more resistors in series. Now connect the last resistor with the ground leg of the bridge rectifier. Now connect the secondary wires of the step-down transformer with the AC legs of the bridge rectifier. Now insert the 2N2222 NPN transistor into the Vero board. Now connect a 10K resistor with the collector of the 2N2222 NPN transistor. Now the emitter will be connected with the ground and will connect another wire with the collector, which will be then connected with pin number 2 of the Arduino, and will connect another wire over here which will be connected with the 5 volt pin of the Arduino. So now you can see the soldering is completed. The black wire, which is the ground wire, will be connected with the Arduino's ground. The green wire will be connected with pin number 2 and the red wire will be connected with the Arduino's 5V. One last connection. Connect the base of the 2N2222 NPN transistor with the voltage divider circuit. I just connected a wire from here with the base of transistor. So now our soldering is completed. The LCD soldering is already covered in my previous tutorial. The link is given in the description. All the connections are done as per the circuit diagram is explained. Now let's have a look at the programming. H include liquid_crystal.h. H means that this is a preprocessor directive and .h means that this is a header file. Then we define some pins. RS is connected with pin number 9 of the Arduino. EN is connected with pin number 8. D4 with pin number 7. D6 with pin number 6. D6 with pin number 5 and D7 with pin number 4. Then define some variables. Initialize the library with the numbers of the interface pins. This is a user-defined function and is used for counting the pulses. This function is called every time when an interrupt is generated. As you know, my friends, each and every Arduino Omega program has at least two functions, which are the while setup and while loop function. While means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. Initialize the LCD. Activates the serial communication for debugging purposes. 9600 is the baud rate. Attach interrupt is a function which takes three arguments as the input: 0, fric_fun, which is a user-defined function, and falling. Interrupt 0 is digital pin 2, so that is where the output from the transistor is connected. Triggers on falling change from high to low, and the function which will be called. Initially we set these variables to 0. Then starts a while loop function. Update frequency every second. Don't process interrupts during the calculations. We simply disable the interrupt while performing calculations. For this we use the detach interrupt function. Then a formula for finding the frequency. These instructions are used to display the values on serial monitor and 16x2 LCD, and then again we enable the interrupt using the attach interrupt function. Restart the interrupt processing. I've already uploaded this program. Let's watch this project in action. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.